Hi, and welcome to a special edition of Backer Breaks It Down, where I go over what we covered during our live in-person class session. Okay, and so in class today, we looked at the basics of proofs. Okay, and so we're going to talk about like what are assumptions that we can make from a diagram, what are conclusions that we can draw from given information, and then we're going to take a look at some pretty basic proofs. Exciting stuff. Let's get started. Okay. Assumptions from diagrams. So you have heard me tell you this or just say multiple times, we never want to assume that any diagram is ever drawn to scale. And there are other things that we should never assume as well, but let's talk about the few things that we can. So we can assume straight lines and angles. Okay. So like in this diagram below, I can definitely, I'm going to read this statement here. It says angle RWT is a straight angle. And so here's, I'm sorry, angle RWV. And so when I look at my diagram, I could be like, yeah, that's definitely a straight angle. Okay. And so that is something that, yes, I can assume from the diagram, and I can be accurate when I do so. I can also assume linear pairs. And so they mention in our statements below here that angle PRV and SRW form a linear pair. So let's check this out. So here we have angle PRV, and then here's angle SRW. Well, a linear pair is when you have a line that's been split into a pair of angles, right? You can easily identify such angles as being a linear pair. And in our diagram down here, yeah, those are definitely a linear pair of angles. We can assume collinearity and betweenness of points. So like down here, they say R is between P and S. Okay, so would you say that R is indeed between P and S? Yeah, I would as well. And then the last thing that we can assume are vertical angles. Vertical angles are formed anytime you have two or more intersecting lines, you get pairs of vertical angles. And so I can look at a diagram and identify vertical angles. So down here, statement A, it says that angle NWR and angle NWS are vertical angles. So here's angle NWR, and here's angle VWS. And so, yeah, those two angles would be vertical angles. Okay, so that's fine. Some things that you should never assume. You can't assume right angles. You can't be, well, it looks like a right angle. No. If you see like what looks to be a right angle and there's that little box there, oops, then it's a right angle, okay? But you should never assume that an angle is a right angle just because it looks like it. You should never assume congruent segments are angles just because they look like they're congruent. You should never assume relative sizes of segments and angles. So going back to some of these statements we haven't addressed yet, statement B says angle V is a right angle. And honestly, we can't assume that. I don't see a little box there, okay? What about statement D, angle P is congruent to angle T? I don't know. I mean, they might look to be congruent, but I can't make that assumption, so no. And then what about statement G, NP is congruent to VT? No, like I don't know that. But speaking of congruences, like one way that they can tell us, hey, yeah, these things are congruent is to use like tick marks or arc marks to show us segments and angles are congruent. So like in the first two diagrams right here, I'm seeing identical markings indicating that segment HG is congruent to segment RS because I've got that like identical marking indicating so. Okay. I could also, for the first two triangles, I could safely say that angle K is congruent to angle T because they both have like the arc mark with the little slash through it, so it's an identical marking. And the third diagram, I should say, I can safely say that angle W is congruent to angle X. I can say that segment WZ is indeed congruent to segment XY because of those identical markings. I'd also like to take a moment and point out that in this example here, I was using a single letter to name my angles. That's because it was absolutely safe to do so. Like there weren't any other angles that I could possibly be talking about, okay? Whereas like in something like this, if I simply said angle B, would you know what I was talking about? And the answer is no, because this could be angle B, this could be angle B, the straight angle ABC could be angle B, okay? So I would have to use 3 letters to indicate like which angle B am I talking about. So ABD makes that nice and clear. So we can use a single letter if like there's absolutely no question what angle you're talking about. Otherwise, the safest way to name an angle is with 3 letters. So let's talk about conclusions that we can draw, okay? Because like we're going to be working with proofs and they're going to give us information. And whenever they give us vocabulary, we have to draw a conclusion. So let's talk about midpoint, which we've worked with midpoint in the past, so it's nothing new to you. The definition of midpoint says, if a point is a midpoint of a segment, then it divides the segment into 2 congruent segments, okay? So when I'm working on a proof and they give me midpoint, I want to be thinking about this definition, right? So M has divided the segment into 2 congruent segments. In this diagram, we're talking AM and BM. So in a 2-column proof, underneath my statements, after I write down my given information, I would then write down what I'm concluding. So I am concluding that segment AM is congruent to segment BM, and I'm doing that based on the definition of midpoint. Okay. Now, all of these reasons that you're going to be using in your proofs are on your summary sheet, okay? And notice that I am using simply the title, okay? So in italics is what the actual definition says. So if you're uncertain what you can conclude, you can read it, and it will tell you that you can conclude there are 2 congruent segments, okay? So let's talk about definition of bisects, right? So when you are given that a ray bisects an angle, you can conclude via the definition that the angle has been divided into 2 congruent angles. So here we've been given that ray AW bisects angle TAO. So I can conclude that I have 2 congruent angles. So when I look at my diagram, I can easily see, oh, it's these 2 angles right here. I must give them each a 3-letter name. So I'm going to say that angle TAW is congruent to angle WAO, and I'm doing that using the definition of bisects. For our next definition, we have definition of perpendicular. I never write the word perpendicular. I just use that symbol, okay? But we've worked with perpendicular before. So we're going to use definition of perpendicular when we are given perpendicular, okay? And the definition says if 2 lines are perpendicular, then they intersect and form right angles. So that's going to be your conclusion when you're given perpendicular. You're going to be like, well, this is a right angle, okay? So here, when they say that ray GR is perpendicular to ray GT, I see that perpendicular symbol. I want to be thinking right angles. And so I can say that angle RGT is a right angle. And my reason is definition of perpendicular. Okay, so let's expand on this. We've just been drawing conclusions. Let's use these in a proof, okay? And so a theorem that has been proven says if 2 angles are right angles, then they are congruent. So we're also going to use this, okay? So when you're writing a proof, my advice is to start one given at a time. Write that one given in your 2 columns. Pause, since it is vocabulary, and draw a conclusion. So here they said that segment AB is perpendicular to segment BC. That means that angle B is a right angle. And why is it a right angle? That's right, because it's perpendicular. So definition of perpendicular. Then you're ready to bring your next given into your proof. DC is perpendicular to AD. Write it down. Pause. What can you conclude from that? So DC is perpendicular to AD. That means angle D is a right angle. For the reason, definition of perpendicular. So we've gone through all of our given information, okay? We're trying to prove that angle B is congruent to angle D, which means angle B must be part of our proof, and angle D must be part of our proof. Angle B is in our proof, because we said angle B is a right angle. Angle D is also in our proof for the same reason. So why are these 2 angles congruent? That's right. If 2 angles are right angles, then they are congruent, or like it says on your summary sheet, right angles are congruent. Okay. So let's talk about something called the transitive property. Here's the transitive property according to Peter Griffin. Okay. So he says that kerosene is fuel. He says that Red Bull is fuel. He says kerosene is Red Bull. Why? Because both kerosene equaled fuel and Red Bull equaled fuel. So they both equaled the same thing, which means them both equal to each other. And that is essentially what the transitive property is saying. So when you read the formal property on your summary sheet, it's kind of mind-boggling because it says if angles are congruent to the same angle, then they are congruent to each other. So if angle kerosene is congruent to angle fuel, and angle Red Bull is congruent to angle fuel, then angle kerosene is congruent to Red Bull. Or like A equals B and B equals C. What does that mean? That means A equals C. Okay, so the transitive property can be used to prove that angles are congruent to each other because they're congruent to the same angle. Can also be used to prove segments are congruent to each other because they're congruent to the same segment. Okay. Vertical angles, we've talked about these before. Remember, we are allowed to assume vertical angles from the diagram. Okay. And we've used this theorem before, vertical angles are congruent. Okay. So using vertical angles in proofs, the very first thing you have to do is you have to identify a pair of vertical angles. Your reason will be assumed from the diagram. Then you can say they are congruent. Reason vertical angles are congruent. Okay. So like that's kind of illustrated in these 2 points right here. First, I'm saying they are vertical angles. Then I'm saying they're congruent. So it's like a 2-step process whenever you want to use vertical angles in a proof. Okay. So let's put these 2 ideas together here. So in this proof, we are given that angle 4 is congruent to angle 6. So it's a congruence given. I write it down in my 2 columns. I mark my diagram. And that's it. Okay, all right. So then what? Well, for guidance, let's look at what we're trying to prove. We're trying to prove that angle 5 is congruent to angle 6. So in order for us to like be ready to do that, angle 5 must be in our proof, angle 6 must be in our proof. Right now, angle 6 is in our proof. So what about angle 5? How can we bring angle 5 into this proof? Yeah, angles 4 and 5 are vertical angles. So let's bring 5 in. So we could say that angle 4 and angle 5 are vertical angles. Why are they vertical angles? That's right. We're assuming that from the diagram. Assumed from diagram. Because like we are allowed to do that. Okay, then what? That's right. We should immediately follow that up with that angle 4 is congruent to angle 5 because vertical angles are congruent. So now angle 5 is in our proof. So we just proved that angle 5 is congruent to angle 4. Okay. So once both of these angles are in your proof, you're probably ready to prove they're congruent. So notice angle 6 in step 1 is congruent to angle 4. And in step 3, we have angle 5 is congruent to angle 4. So they're both congruent to angle 4. What is that? Yep, that's your transitive property. Okay, because they're both congruent to angle 4. That makes them both congruent to each other. Kerosene equals Red Bull. Okay, so those are the basics of proofs. Assumptions from the diagram, there isn't a lot we can safely assume. When it comes to the proofs, vertical angles are going to be a big one. Vertical angles are very, very helpful in many proofs. They don't tell you that you need them. Okay, so I call vertical angles look-fors. So when you're like realizing, I need some more things here, look for those vertical angles, okay? Identify them, reason, assumed from the diagram, say they are congruent, reason, vertical angles are congruent, okay? When you're writing your proofs, take it one given at a time. If it's a congruence given, mark your diagram. If it's a vocabulary given, draw a conclusion, okay? And there you have it. And that's how Becker breaks it down. I'll see you guys next time.